Welcome back to Disruptors Unleashed, the series that explores the disruptive technologies shaping our world. In our previous episode, we looked at the future of manufacturing with four industry trailblazers: Stefan Siro and Florence Verzeland from Dassault Systèmes, David Rowan, founding editor-in-chief of Wired UK, and Paul Armstrong, founder of London-based advisory firm Hereforth. In this episode, we take a look at how virtual twins are radically transforming sustainability with Arvind Krishnan from Lifecycle Insights and Philippe Bartisol from Dassault Systèmes.
Hello and welcome to this podcast. I'm your host, Arvind Krishnan, a senior industry analyst at Lifecycle Insights. Today, we have with us Mr. Philippe Bartisol to talk about the industrial equipment sector and, most importantly, the impact that Dassault Systèmes' virtual twin experience can make to the companies in this sector. Philippe, welcome to this podcast.
Hello, Arvind. Thank you for having me.
Yeah, you're most welcome, Philippe. Thank you for being here. Philippe, can you tell us a bit about yourself and your current role at Dassault Systèmes?
Yes, with pleasure. So my name is Philippe Bartisol, and I'm the Vice President for the Industrial Equipment Industry at Dassault Systèmes. I joined Dassault Systèmes 12 years ago after several managerial positions in the industrial equipment industry at a packaging machinery company group. And actually, if you look for Dassault Systèmes in terms of industry revenue, industrial equipment is the third industry in terms of revenue for Dassault Systèmes.
So that gives you a lot of experience in the industrial equipment sector, and we have the right person that I'm conversing with to talk about this. So as I said in the beginning, we will talk with Philippe about industrial equipment companies and the sector. So let us start with the trends in this particular sector. I'm sure, Philippe, this sector has undergone an enormous amount of disruption and transformation in the last few years. So what are the trends do you notice in this particular sector? Is there something that you see as quite unique to this sector? Maybe share your experiences and your knowledge with the audience today.
Yeah, so post-COVID, what we saw is that our customers are switching from something hyper-efficient to much more agility in the value network and in their processes. And with this, also a better evaluation of their risks and the management of their risks. Of course, we also have the production of one in the industrial equipment industry. In many segments, you will have on the same production line a small piece of equipment, then two large ones, then a medium one, then three small ones again. So ad hoc production is super important. From a technology standpoint, when it comes to the product itself, we have more and more self-aware connected systems, which makes system engineering more pregnant and more important than before in the industrial equipment industry. You know that system engineering comes from the aerospace industry, but it's for example, with AMRs, with autonomous mobile robots, you need to really have a system view because you need to take in all the factors in the navigation and in the processes that the autonomous mobile robot will execute. But the two most important that we see right now are, of course, circular innovation and sustainability and equipment as a service. And maybe when it comes to sustainability, maybe we might not globally be looking at the right factors in sustainability because we all talk about life cycle assessments. What is my contribution? How much CO2 do I produce when I execute this action or this process? We are talking about the recyclability of the piece of equipment, but given the fact that the piece of equipment might be in the field for 10, 20, 30 years, probably the biggest impact that we can make on preserving the environment is refurbishing, modernizing, retrofitting the pieces of equipment, the machines. And that is prior to the recyclability. So if you look at a DevOps loop, you will go to engineering, you will create the next generation product, you will manufacture them, sell them, then install the pieces of equipment at the customer location. And then the customer will experience the use of the equipment, the value he's getting from that. And for a certain time, he's very happy with the value he's getting, but that after a certain time, probably the value is not enough. And either the customer or the machine OEM will advocate for a retrofit. And that retrofit could be for sustainability purposes, for energy saving purposes, for a modernization in terms of IoT capabilities, for example, or control capabilities. It could be not so much now for the productivity, but better agility in the machine being able to produce or to transform a larger type of products. Then you go back to engineering, you engineer the retrofit, you manufacture whatever needs to manufacture, and then you install the retrofit, or you retrofit actually the piece of equipment. And then you have another months, years of value experimentation, value experiencing. And then after that, you will ask yourself, either the customer or the machine OEM, do I get the right value or should I retrofit again? And maybe you will do 3, 4, 5 retrofits in the course of 20, 30 years. And maybe we should, or the machines OEM, the equipment OEM should think design for retrofit. Because it might be that it is by retrofitting several times the same piece of equipment and not creating a new machine that we will have the best impact, the most positive impact on the environment. And that comes to the last trend, which is equipment as a service. Right now, probably 99% of the market is the traditional sell and service, meaning the machine OEM will sell a piece of equipment. And then once it's installed and the site acceptance test, the contractual test has been successfully performed, then the transfer of ownership, the equipment is transferred legally to the user and start the 10, 20, 30 years of the service, starting with the warranty period. And most machine OEMs will sell the machine with a very small margin, sometimes no margin at all, and will make more money on the service thereafter. You could count for the service revenue to amount to 20 to 50% in a machine OEM, depending on the segment. Revenue in a machine OEM revenue, and so 20 to 50%, but in terms of EBIT, it's probably double this, so probably 40 to 80, 90% EBIT contribution that the service period or the field period will bring to the machine OEM. So in essence, for machine OEM, the EBIT creator, the EBIT engine is in service, and yet so far, the different divisions were not working together. The person in charge of service usually does not leverage the assets created in engineering and manufacturing. So that is the traditional model, which is good in terms of revenue and in terms of margin, but it is not very effective because it's a siloed model, because you have engineering in a silo, manufacturing in a silo. So now engineering and manufacturing are working more and more together, but the service activity is still in a silo mode right now. The new business model, or the business model that all machine OEMs are looking at, some are testing, but very few are executing at scale, is equipment as a service, whereas either you lease the piece of equipment, but to be honest, most machine OEM do not like to keep the asset on their books. So usually they sell the asset to a financial company, and that financial company will then invoice the customer, part produce or part transform, so per output. So it's an outcome-based invoicing from this financial company that might be created as a special purpose vehicle just to hold the assets of a certain plant to the line owner. And in that case, this is being experimented. It's already the case for some compressor businesses, and it's being experimented by a lot of machine OEMs right now. And what it does is that it is gluing or bringing the interests of the line user, the machine OEM, and the special purpose vehicle or the financial, specially created financial company together. They all have the same interest, which is the machine OEE in the field, and the OEE stands for overall equipment efficiency. So everybody's aligned, everybody's interest is aligned alongside the utilization of the piece of equipment in the field.
So I heard a few things. Equipment as a service is the future for industrial equipment manufacturers. I also heard the importance of design for retrofitting, which is really what the upstream R&D and engineering must do, at least for their future designs and the future equipments. And third is the importance of making sure that there is sustainability throughout the life cycle of these equipments. So let's just jump into equipment as a service, which is really such a burning topic in this particular industry. So it really looks like, to keep the interests of all the stakeholders aligned, operations become very important. So it looks like effective operations can actually enhance the revenues and the EBITs of the industrial equipment manufacturers. Now I'm going to come back to something that you are very passionate about, which is the virtual twin experience of Dassault Systems, and connect the two. So how can the virtual twin experience aid these companies? How can they exploit this particular piece of technology in their operations and use it effectively to improve their numbers and become more profitable and become more valuable in the eyes of investors?
Let's look at the different twins, actually the different facets of a twin. Before putting something in operation, I'm working for a machine OEM and I'm reflecting on my next product generation. Then I need to go to the market and investigate, get a number of requirements, look at the range of product I want to address and what are the related requirements. And then I start, hopefully, from a system viewpoint, and then I start the design and the simulation, or mod sim as we call it, modeling and simulation almost at the same time. I will then work on the manufacturability of my next generation, product generation, and I will work on the serviceability and especially the retrofitability of that future range of equipment that I'm about to put on the market. And then in the end, I will work on the recyclability. Right now, actually, to be honest, our machine customers, they're not so much working on the serviceability and the retrofitability. They start working quite well now since 5-7 years on the manufacturability during new product development or new product introduction, NPD or NPI. But we need to guide them towards the serviceability and the retrofitability. So what we did at Dassault Systèmes is that we introduced a new item in the 3D Experience platform, which is a service item, which is at the same time a CAD view and a BOM view. And you can, using this service item, together with the notion of consumables, spare part kits, and then MTBF, MTTR, mean time between failure, mean time to repair for the spare parts, and documenting this during NPD or NPI, during the product development itself, and forcing the development engineers, who do not like to do so, but it's really in the interest of the machine OEM. If you manage to force them to really document this and work on this, then you prepare the ground for the service time thereafter, for the 20-30 years of machine in operation thereafter. So you have your engineering twin when you do new product development. Then you might have a sales twin, a sales virtual twin. When you might have before a marketing twin, which is a generic one. The engineering twin is also generic. It is not, at that time, you were developing a complete range of product. You're not developing for a given customer, or you're not doing ETO. You're developing the whole range. And then you put it on the market and you start quoting. The minute you start quoting, the twin you quote becomes a specific twin because it is for that customer need at that customer location. And hopefully you will be successful. You will modify your quote maybe 4, 5, 6, 7 times. And you have a hit rate of maybe 10, 20%. And let's say you were successful, you get a purchase order. Then at that time, our customers are now asking us for a specific twin, a specific manufacturing twin, and a specific engineering twin per machine ordered until installation. And then thereafter, they're asking us in the 3D Experience platform to provide them with the field twin of that piece of equipment as it has been just installed in the field. And that field twin or that virtual twin in operation will have 2 views. It will have an engineering view and a service view. Why so? Engineering view, because in case of technical issues, you might have to go back to the engineering view. And service view, of course, because you will execute your maintenance program, which are regular, which could be preventive or predictive. And then from time to time, you will propose retrofits, as we were discussing before, in order to extend the life of the machine, potentially to repurpose the machine, but usually it's to extend the life of the machine, augmenting the value and fitting the machine for another 2, 3, 4, 5 years of life on the ground. That virtual twin in operation, which is at the same time engineering and manufacturing, and which has a 3D view, you will project all the events that are taking place on the field, in the field, to that machine, onto the twin. And Arvin, think about it. You maybe 15, 20 years ago, we switched in engineering when we did engineering reviews from 2D to 3D. And really the reviews are around the 3D. I mean, you're projecting the 3D, whether you are in Los Angeles, in Rome, or in Shanghai, everybody's looking at the same thing. And why can't it be possible for the service activities? And now that our customers are asking and that the platform editors are proposing specific twins for machines in operation, and we are starting to populate the 3D Experience platform with these specific twins, they will be able to do reviews for service around that 3D twin, which will contain the engineering and the service view, the retrofit, the maintenance, work instructions, the maintenance processes, and the retrofit possibilities. And you will project what is happening. For example, you have an issue there or you have a customer claim. You might annotate the 3D twin in the field directly and just look at this. That twin will be used for 10, 20, 30 years, whereas in engineering, it's only a period of 4 or 5 years, or the quoting time is, 6 months. Manufacturing time might be 6 months to a year. So here is really the largest time frame. And in my eyes, this will become the mostly used industrial metaverse, if you will, but not a gaming metaverse, a metaverse that is really there for a purpose and around which we can, everybody that has a take in the machine OEE, overall equipment efficiency, will gather around and will contribute to. Now, Arvin, that has a caveat. And the caveat is, if I'm a field technician, for example, I'm preparing my next mission. I'm based in Spain, and I need to go to a machine, for example, in Portugal. Prior to packing my suitcase, I will study the twin, study everything that happened, potentially collaborate with a first level of service or some engineering guys around the twin, get the right spare parts with me, the right work instructions, and go there. And this will allow me to do my job much quicker. And remember, I'm a field technician, so I'm representing the machine OEM, but my workspace is at my customer plant. So I'm operating right in the front of the customers. So this is quality perceived. What I'm doing will set the stone for how the customer will perceive my company, because the sales guys are selling the first machine, but you know that the service guys or the field technicians will sell the second, the third, and the fourth, or the retrofit of the installed ones. I do what I have to do much quicker and with a perceived quality that will be enhanced in the eyes of the customer. And then I go back home. But then somebody has to update the virtual twin in operation, because if nobody does, the next technicians who will have to go there in 2 months' time, he will get the wrong information. He will come with the wrong parts, the wrong work instructions, and then we will have the traditional way of working, which is the phone and some photos, and it will take hours, and the technician will have to come back. So we will have to sit down with our customers and really study with them, in which case they want to update the virtual twin in operation, in which case not. And as a RASKey, who does it? Is that the field technician? Is that the first level of service in a country? Is that service but centrally? Is that engineering? All this has to be discussed. And you see that it's a question of offer and demand. The offer is there now. We are proposing this right now. And our customers are requesting this. What we are seeing is that in the RFQs, in the request for quotation that our customers are sending for when they want to really reflect on the next PLM or product platform for the next 10, 15 years, you have the service items, you have the service bombs, and they are asking the editors to enable them to produce, to create this specific virtual twins in operation per machine created. So it's going to be a whole new world, whereas the ways of working in engineering will apply to service. It will take some time, but the technology is there. The offer is there. It's possible right now. The most advanced customers want it right now. It will entice some change management in the roles and responsibilities of all the parties that are taking part to the relevant OEE of the machine, meaning that the machine, the piece of equipment is mostly used. And from a sustainability standpoint, all parties have the same interest, is that that production line or that piece of equipment be used as much as possible, because if so, the customer doesn't have to buy a new piece of equipment. He's super using, hyper using what is already existing, which is exactly what you and I and most of the people that are listening to us today are doing in their private life, which is they are starting to favor reuse or buying either clothes or objects that have been already used, or rather than buying completely new ones.
Absolutely, Philippe. I think there is a renaissance, I must say, for the circular use of things. And it's interesting to note that the industrial equipment, common people don't think of those things as, oh, can I reuse them? Can I repurpose them? Can I repackage them? Can I salvage materials and use it to do something else? And I think the ability of your virtual twin in the platform just opens up a plethora of opportunities that people haven't conceived today. And I think that's the possibility, which I think is the biggest takeaway from here. And let me get back to a very interesting thing you said about the service technician wearing a completely different hat. I might say an ambassador for the company, because once the sales is done, and maybe after 5 years, the customer is seeing somebody from the OEMs or somebody on behalf of the OEM. And here is an opportunity for the service technician to actually champion the company and become a great ambassador. And I like the way how you mentioned how the virtual twin experience is actually going to help this particular person execute her job quickly, execute her job efficiently, and actually lead to more services. And that leads me to the next question, right? I believe that there are probably opportunities for more value-added services around that equipment that these ambassadors may uncover during their visits. Are there any ways by which the virtual twin experience can exploit this, leading to probably more revenues or new product lines in the future?
Absolutely. You will be able to apply, compared with the virtual twin in operation, you will be able to compare the actual virtual twin of new machines that you would sell today to the twin that has been installed, of the machine that has been installed. And by comparing this, you would come immediately with opportunities of retrofits. Right now, this is a very cumbersome process because the machine OEMs, they have an install base somewhere in the hierarchy, and they just have usually an EBOM, and that EBOM is usually not up to date. So they do not have what is needed to do a proper scanning of all the sales opportunities for retrofits. And with the twin, with the virtual twin in operation, comparing this to the twin of the machine, if they were to sell a machine today and looking at the differences, they will be able to come with campaigns, with retrofit offering campaigns that would be also, when you propose this offer, you will propose the offer in 3D rather than just paper and a bunch of numbers.
Excellent point, Philippe. I can really see how not only those retrofits are being proposed, but at the same time, the ROIs for those retrofits, where the decision maker needs to do, those things can be available on demand, either by the person who's doing the service or by the salespeople who are in communication with the customer. And the whole thing in 3D with the existing machine gives the customer a real idea of, well, do I have the space to do that? I mean, does it even make sense in my context to do that? So it's really personalizing and contextualizing the offer for a customer.
Absolutely. And if we go one step further, you could imagine that the customer will want to have that twin as well. But there is something a bit strange that is happening, is that the line user or the machine user, the purchasing guy, is purchasing, a piece of mechatronic equipment. He knows how to purchase spare parts, service, installation, warranty, but he very seldom requires for having access to the twin. And the machine OEM, on its side, it doesn't want to give away the twin because it's very precious. This is IP. We have the capability on the 3D Experience platform, with the capability with our brand 3D Excite, to simplify and beautify the twin. And you can choose how much you want to simplify. And so that it might be that the machine OEM or the line builder be comfortable enough with the level of simplification that he is okay to sell or rent the twin itself. And by the way, in the case of equipment as a system, of course, that virtual twin in operation is super interesting with the current business model where you sell and then you service. But with equipment as a service, it's not useful. It's a prerequisite. It's a prerequisite of that pay-per-part model, because you have, as a machine OEM, you have much more take to the machine performance. So you absolutely need that twin, and you need to keep that twin updated. So again, this virtual twin updating mechanism needs to be worked out and needs to be reflected upon.
Well, a very interesting point that you brought out, Philip, that for the EaaS model, the equipment as a service model, to even work, having some sort of virtual twin for every machine that you sold is not just a nice thing to have, but certainly you will not be able to do business without that. So I guess that's something that the executives have to take note, that they need to have some sort of virtual twin of every machine that they sold and keep to monitor them. And they can probably get all data associated with that virtual twin as it is in operation, because you might foresee some things that the operator may not foresee. And it is in your best interest to go ahead and get that thing done. Otherwise, maybe 3 months down the line, you're going to have a big disruption in terms of the usage of the machine. And that could lead to impacts in your revenues because you had some service level promises that you need to uphold.
Alvin, you pointed exactly the difference between an EBOM and the virtual twin is that the virtual twin you can simulate, and you can simulate into the future with what if scenarios. What if the water consumption of the machine differs, or the water source is different, and then the quality of the water, or what if I have a very short electricity cut there, you will be able to simulate your specific twin, every specific twin. So you might think that it will cost some money to entertain a twin per piece of equipment. But think about 15 years ago when we thought about IoT and the small objects. When people were writing 15, 20 years ago, well, in the future, every object, even the smallest ones, will be connected. And people laughed. Well, I believe that for large machines, already today, most advanced customers, they want specific twins. For smaller pieces of equipment, it will come. And I would even guess that for cars, it will come as well, because there's a whole business model around it. So probably we might see an industry of specific twins in operation in the future, to which you will be able to connect the IoT data. The similar way we saw the wave of connectivity for even smaller objects 10, 15, 20 years ago.
Philippe, I think we can go on this topic for a long time. Looks like that is a passionate topic for you and for me as well.
Yes.
But in the interest of time, I think we may have to wind up this podcast conversation now. So, Philippe, thank you again for this engaging discussion. You know, I'm very certain that the engineering executives who are hearing this podcast will get some new ideas and can certainly benefit from the insights that you shared with us. You know, they might embark on a strategy to incorporate virtual twin experiences for their particular operations. So thank you again and have a nice day.
Thank you very much, Arvin. Have a nice day. And this is a completely new era for the service activities worldwide.
Disruptors Unleashed is produced by Dassault Systèmes. For more episodes, follow us on Apple Podcasts, Spotify, Deezer, or your nearest audio streaming platform. To learn more about Dassault Systèmes, visit us at 3ds.com.